Hi, I'm Randall Heyman, a university academic who's involved in mathematics. I've created a number of Corona Help playlists for quick turnaround videos on primary and secondary school and university level mathematics. So if you'd like me to make a video for you or your students, just comment below any of my videos or drop me an email at coronahelpmathematics@gmail.com. So I set this little exercise yesterday. Let me direct your eyes here. A little exercise to try if you've been following what I've been doing on ideals. If you have, I apologise, I've changed some of the videos around, deleted some, and tried to get it all sort of consistent and hanging together. Unfortunately, different books define some of these things slightly differently, and so it can throw up some problems, as I am just taking different things from different books. Okay, so here's the question. Suppose I and J are ideals in a ring, ideals of a ring are. Is it true that so this is the union of A and J is an ideal of R? Okay, so let's push this up a little bit. I've got there the conditions in black above, just to remind us. Actually, let me just move it down so it's clear of all those silly symbols. Okay, so we can rub that out and rub that out. Now, just in terms of thinking, if this is J and this is I, for example, then all this area is the union here of J. Of course, you can have, I've drawn them overlapping, intersecting, but you can have disjoint sets I and J, in which case this is the union. Interesting question. Someone did ask me actually, do we require them to be disjoint or not disjoint or whatever? So interesting to ask yourself, can you have two ideals like this that are disjoint? Can you have two disjoint ideals of a ring? Another good exercise that you might like to have a look at, and if you want to develop that further, let me know. Okay, but at this stage we're not told they overlap or they don't overlap. The important thing here is that we're not told anything about the rings. You know, it's not necessarily the integers or the ring of polynomials or the ring of continuous functions or something like that. So, and the other thing is we don't know if it's true or not. Now, the thing is it's normally easier to prove something's not true than it is true, because to prove it's not true, I just have to give a counter example. So, well, sometimes you sort of think that the answer's true and so you'll head off that way. Sometimes you might want to just try and prove that it's not true to get an insight, which will then help you prove that it's true. So these are the sort of things that come with a bit more experience. So if I was in this, if someone had this in an exam, you know, if you can see an answer straight away, fine, go for it. But if not, I would be tempted to think a bit. So I would let R equal, as a start, the integers. So here we've got the integers. And then we need some ideals. So we could have, you've seen me have previously 7z, z, and then we could have, say, 2z. Oh, sorry, I'll write it in there. So this is just, we're just mucking around, but often in doing this, it'll get you to the point where you can see a way to go. So actually what's in here, not that it matters actually that much, 14z. This is the numbers here that are divisible by 7. So 7 would be in this one. 21 would be in here, -7. In here we'd have 14, -28 would be in here, 0 would be in here. And here's the even numbers that are not divisible by 7. So 6, 2, okay. So now if we're going to disprove it, if we direct our eyes out here, we have to either show it's non-empty, that I union J is non-empty. Well, we've seen that it's not non-empty. It's here. We can see it's got, sorry, here we can see with my very scrappy Venn diagram, there are elements there. So in this case, we can't get anything with that. So I think we're going to have to go for, we're going to have a go for one of these. So let's just rub this out. So what about this? What my thinking is that when I look at the A minus B as an element of I, of course, now we're talking about, we're saying if two things are elements of I union J. So what we would have to show is, so there's a bit of confusion here with the I's, but that's mathematics, I'm afraid. We'd have to show if A and B are elements of I union J, then A minus B is an element of I union J. And this is, of course, I haven't said this often, but this is for all AB that are elements of I union J. And then we would have to show that if A is an element of I union J and say R is an element of the ring, then AR equals RA would have to be an element of I union J. So I think the one to go for is this one here. Because, why do I think that? Because if you've got a multiple of 7 and a multiple of 2, and you take the difference, it's not going to be a multiple necessarily of 7 or 2. So I think that's what I'm going to do. That's what we're going to do. So if you like, I'm going to think of this one here, 7, and this one here, 2. Okay, so let's rub this off. And let's try and answer the question now. Is it true? So I would say I union J is not an ideal of R. And proof. Now remember, for it to be true that I union J is an ideal, it has to be true for every ring R and every I and J that are ideals of R. So I could just say let R equal the integers. I can be 7Z, the multiples of 7, and J can be the multiples of 2 times 7, in other words, the even numbers. Then 7 is an element of I. 2 is an element of J, but 7 minus 2, what's 7 minus 2? Basic mathematics, basic arithmetic, is 5. And 5 is not, so actually I'll do it a bit more fully. So if I take them, now I've just got to show that 5 is not an element of I union J. Next, 5 is not an element of I. 5 is not a multiple of 7. And 5 is not an element of J, because J is the even numbers. So 5 is not an element of I union J. If 5 is not an element of I and it's not an element of J, well then it's certainly not an element of I or J. So if you wanted, you could put so ending the proof. So I hope that's been of interest to you. You maybe had a bit of fun playing around with that exercise in the last 24 hours. If you've got any questions on this or any other branch of mathematics, please write a comment below this video or any of my videos, or you can email me at coronahelpmathematics@gmail.com.